Today we're going to be looking at explicit formula and recursive formula of arithmetic sequences. This is with linear functions, lesson 2.2. This is just part one of two parts right here. So the first thing we're going to be doing is looking at explicit and recursive formulas, because today we will write the explicit formula for an arithmetic sequence and use it to find the nth term. We will also write the recursive formula for an arithmetic sequence. So you'll be able to say, I can write the explicit formula for an arithmetic sequence, use the explicit rule to find the nth term, and write the recursive formula for an arithmetic sequence. Now, I've already gone ahead and written down all these answers for you, so let's review a minute. When we look at this first one right here, the first thing we have to come up is with the pattern, the common difference. So we're going to start at the back and go backwards. So if I use my graphing calculator right here, and I'm going to turn it off, and then I'm going to go back and turn it back on, because I'm going to find the common difference. I've already written this out for you, but we're going to go with a negative 11 minus negative 4, and you see that it comes up as a negative 7. Then you're going to say a negative 4 minus 3, and you'll come up with a negative 7, and then 3 minus 10 right here. And you see that we have a common difference of a negative 7. It didn't take but a few seconds to come up with this common difference using a calculator. So I'm going to start the back and go backwards to come up with my common difference. Now, I see that my common difference is a negative 7, so what I'm going to do is clear this off. I'm going to type in my first term, which is 10, and hit enter. Then I'm going to turn around and add my common difference of a negative 7, so this is my negative and my 7, and I'm going to hit enter, and I see my next term is 3. Hit enter again, my next term is a negative 4. Hit enter again, my next term is a negative 11, and then I'm going to see my next term is a negative 18, negative 25, negative 32, and it matches it all the way up here. So I'm saying 10 plus a negative 7 gives me 3, and I'm going to use that common difference all the way across. I'm going to do the same thing for this next one right here. So when I look at this one right here, I start at the back, and using my graphing calculator, I'm going to put this in. 19.8 minus 15.7, you get 4.1. Then put in 15.7 minus 11.6, and it gives you 4.1. 11.6 minus 7.5, and it also gives you 4.1. So my common difference right here is 4.1. Now, when I use my graphing calculator, I can very quickly check to make sure that this is correct. I'm going to enter my first term, which is 7.5, hit enter, and then I'm going to add my common difference of 4.1s to it, and then hit enter, 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 enter. And as you can see, it is matching, and then here are my next three terms, 23.9, 28, and 32.1 is my next term. I'm going to do the same thing with these. I'm going to find the common difference, start at the back and going backwards. I'm going to subtract, and you can do it very quickly on the graphing calculator, and only takes a few seconds. And your common difference is a negative 12. Now, I always like to double check to make sure that this is correct, that I did not make a mistake when I was typing this in. So when I look at this right here, I'm going to type in my first term, which is 4, and hit enter. Then add my common difference of a negative 12 to it, and it gives me negative 8, negative 20, negative 32, negative 44, negative 56, and the last term that we're looking for is a negative 68. I'm going to do the same thing with this one on number 4. Type in a 9.8 and hit enter, and then type in negative 4.2. You're going to add it. So when I look at this right here, I'm going to say, I'm going to put in my 9.8, hit enter, and I'm going to add my common difference of a negative 4.2. and it gives me the next term of 5.6, 1.4, negative 2.8, negative 7, negative 11.2, and my last term I'm looking for right here is a negative 15.4. So it matches. It is very quick and easy to find the common difference with using a graphing calculator. Now, look at these right here. On number 5, you see that the first term of the sequence is a negative 24, and the common difference is a negative 15. So if I type this into the graphing calculator, I'm going to type in my first term is a negative 24, hit enter, and then I'm going to add my common difference of a negative 15, and then I come up with my next two terms that I need right here. I'm going to do the same thing with this one. On the next one, you see that on number 7, that the first term is 3/5. So I'm going to go to alpha y equals right here, alpha y equals, and you see that n divided by the d, that is numerator divided by denominator, and that is a fraction. So I'm going to click on that, and I'm going to type in my first term, which is 3. I'm going to cursor down to 5. Cursor out from underneath this using, think of this part as a joystick on your Nintendo games. And now we're going to hit enter. And then I'm going to add my my common difference of a positive 1/5. Go to second, y equals, and hit enter. And it gives you 1. You will type in 1 over 5 and hit enter. So the next one, I see that my next fraction is 4/5, and then 1, because 5 over 5 reduces down to 1. So now I have my my sequence right here. You're going to do the same thing for number 6. So on number 6, the first thing you see is the first term is 12. The common difference is a negative 3.5. So on your graphing calculator, type in 12, hit enter, and then add your common difference, which is a negative 3.5, and hit enter, and there's your 3 terms that you're needing. Now you're going to do the same thing for this first term right here on number 8. You see the first term is 10.5, and then enter that into your graphing calculator and hit plus 2.5, and you will come up with your 3 terms that you need. So with the graphing calculator, type in 10.5 and hit enter. Now add your common difference of a 2.5 to it, hit enter, and if you do not have a graphing calculator, when you type this in, you would have to, instead of saying enter each time, you would just say plus 2.5 and you get 13, plus 2.5 and get 15.5 if you do not have a graphing calculator. Now, on this next part right here, we're going to be looking at formulas. You have what we call the explicit formula and the recursive formula. So when I look at this right here, explicit formula, you can use these formulas to find any term you need without having to determine the value of the previous term. So if I wanted to find the 1,000th term, instead of clicking all the way through the calculator until I reach 1,000, I can just simply substitute it in place of this n right here. When I say a sub n, this stands for any term that I need. The a sub 1 means this is the first term of your sequence, and then the d, whether the d is in front of the set of parentheses or back behind it as it is here, it still means the same thing. That is your common difference. There's always a plus right here in the middle of this formula right here. It will always have a plus. And then you have n minus 1. This n right here and this n must match. This n minus 1 means previous term. So this right here and this is exactly the same. So whether you write the d, the common difference at the end or in the front of the parentheses, it's the same thing. Now recursive rule. The recursive formula of the rule, each term of a sequence is based on the preceding term in the sequence. You must know the previous term before you can find the next term in the sequence. Think of it as recursive reuse. So you're going to reuse the last term that you just put in there, just like what we did in the previous problems. So the a sub n means the nth term. This stands for any term. And then notice that this n minus 1 is down below here. It's a subscript. So a sub n minus 1. And then you're simply going to add the common difference to it. So when we were right here, we had the first term of 10.5. So when I look at this right here, I see that I enter 10.5. So I'm going to enter this in 10.5, and I have to know what my first term is before I can find the next term. So I'm going to reuse this answer right here, and I'm going to add my common difference to it right here. And I'm going to come up with 13. Then I'm going to say 13 plus the 2.5, and I come up with the next term. And I am reusing this previous term right here, 15.5 plus the 2.5. My common difference is 18. So I am reusing this last term. This is the recursive rule. You must know the last term that you are working with and the common difference to it. And I'm going to, before you can get to the next term. So 18 plus the 2.5 will give me 20.5. I am reusing the last term. Now the explicit formula is great if you are looking for, say, the 9th term, 10th term, the 20th or the 100th term, or 1,000th term. You do not want to keep on doing this all the way through 1,000 times. So they came up with a formula called the explicit formula, the explicit rule. I am reusing this right here, this last term, to come up with the next term. So this is reused, this is recursive rule right here. Now, when I look at this next one right here, we're going to use the explicit formula. The thing that you must write that must be the same is this n has to be the same n number as right here. So the recursive rule, what you just did, we reused the last term that you had right here. So you see the 45.5, that would be what we would have, a sub n minus 1. That's a 45.5. Now I hit enter because I'm going to add my common difference of 2.5, and I get 48. So I'm going to reuse the 48 again, and I'm going to add the 2.5 to it, and I come up with the 50.5. That is how the recursive rule works. Now here's how to work with the explicit formula. On the explicit formula, I've already gone ahead and worked these for you. Now, the first thing that we're going to look at is we have to look at number 1. You're going to write the explicit rule and the recursive rule for each sequence. The first thing you have to know is what the first term of the sequence is 35. Then you're going to come up and find the common difference. So when I look at this right here, I look at my common difference, and I'm going to start the back, 23 minus 26. And I come up with a negative 3. 26 minus 32. And I come up, I'm sorry, it should be, let me clear that, 26 minus 29. And I come up with a negative 3. 29 minus 32, and I come up with a negative 3, and then I'm going to take the 32 minus 35, and I just see that this right here is my common difference. It is a negative 3 all the way across. Now I'm going to take this right here, I'm going to take and use it, put it in this formula right here. Now I have written my my common difference at the back. You can write it in front right here, or you can write it at the back. I like writing it in back, so whichever one you prefer. So the first thing I'm going to do is a sub n equals, here's my first term, plus, remember there's a plus right here, that a sub n is a 35. In parentheses, n minus 1 is always the same, always. So parentheses, n minus 1, parentheses, and my common difference right here is a negative 3. So this is the explicit formula. I have taken this right here and written in this format. Now, when I look at this next one, we have to write the recursive formula. Recursive formula, this will always be the same. So a sub n is the same as this part right here, but this stands for the previous term right here. So you're going to write a sub n minus 1, and then simply put plus, and then add your common difference to the n. A positive times a negative is a negative, so you could write it like this or like this. It means the same thing. Now let's look at the next one. So when I look at this one right here, just like before, we're going to find the common difference. I'm going to subtract 86 minus 79 and get 7. 79 minus 72 and get 7. 72 minus 65 and get 7. 65 minus 58, and I see that my common difference is a 7. So if I use my graphing calculator and subtract that, I will get the same common difference all the way across. My first term is 58, so I'm going to substitute it into my explicit formula right here. So when I look at my explicit formula, I see that right here, I'm going to write a sub n, just like in the formula right here. The first term is 58 plus the n minus 1 is always the same, and then my common difference is 7. I chose to write it at the back. Now I'm going to write the recursive rule. So I'm going to put a sub n equals, and remember this part is always the same, a sub n minus 1. And then 7 is my common difference, so I'm just going to put plus 7 right here. Now on number 3, you're doing the same thing. On number 3, you're going to find the common difference. 148 minus 132 is 16. 132 minus 116 is 16. 116 minus 100 is 16. 100 minus 84 is 16. So the first term we have is 84, and the common difference is 16. So I'm going to substitute it into this formula right here. And the first term is 84 plus parentheses, n minus 1 parentheses, and put your common difference right here in parentheses. Now I'm going to write the recursive rule using this formula right here, and it's going to be a sub n minus 1 now plus 16. That is your common difference. Now when you write these right here, do not write a big N. The N is not as big as the A. It is a subscript. It is written down below the line. So it's a sub n right here. Do not write the word an, A-N. It is A with a sub n right here. So it's down below the line. I'm going to do the same thing for this one right here. I see that I have to find my common difference, so I'm subtracting these, and my common difference ends up to being a negative 1,111. My first term is 4,567. I'm going to substitute it into the formula right here that we have. And when I do, the first term is 4,567 plus the n minus 1. Remember, the plus is always the same right here. The n minus 1 is always the same. So if it has a minus right here, it's automatically wrong. If these are out of order, it is wrong right here. So when I look at this, unless this is written in front, it will always be the plus right here. So my common difference is a negative 1,111. Now write the recursive rule. So when I write this right here, I have a sub n minus 1 plus, and then parentheses, a negative 1,111 parentheses, or a positive times 11 will give you a negative, so you can go ahead and put your minus right here and write it like this. So either way is fine. Now on this next part, we are writing, we're finding the first term and also the common difference, and we're writing these. So just like what we did before, we're going to take and substitute in the first term and the common difference. I've already found all this for you, so just pick up your calculator, practice. 75 minus 80 is negative 5. 80 minus 85 is a negative 5. 85 minus 90 is a negative 5. 90 minus 95 is a negative 5. So my common difference all the way across here is a negative 5. I'm going to substitute each one of these in place of the formula right here. So the recursive rule, I'm going to just substitute out. This part remains the same. It's only the D that changes right here. And we have a plus, and the common difference is a negative 5. And just like before, a positive times a negative is a negative. So I could either write it like this or write it like this. So when we're looking at recursive rule and explicit rule, you have to identify the first term and the last term, first term and the common difference right here. So once I do that, and like I said before, just quickly go on your calculator, start the back. 146 minus 131. Oop, it helps if I turn it on. Now, I'm going to put in 146 minus 131 and hit enter. 131 minus 116 and hit enter. 116 minus 101 is 15. 101 minus 86, and it is also 15. So my common difference is 15. Now you always want to check these all the way across to see what your common difference is. Then just put it up here in the formula. So just follow it. A sub n equals first term is 86. This part plus n minus 1 is always the same right here. And then simply put your common difference on the end. And then this part right here is always the same right here. So just copy it down. A sub n equals A sub n minus 1, and then add your common difference to it. So this part is always the same as this. All you're going to do is substitute out the A sub 1 and the D. And on this one, all you're going to do is substitute out the D. Everything else is exactly the same. So you're finding the pattern first. So the very first thing, identify the A sub 1, the first term in the sequence, and then identify the common difference. Once you have those two, you can use the recursive formula right here and the explicit formula substituted in. Now, here we're looking at actually solving problems using the explicit formula. So the first thing that we have right here, go ahead and write this down so that you can pay attention and listen to me. So put me on pause when you do this. Now, let's look at the first term on number 9. So when I look at number 9, I see that we're looking for the 20th term. So as I said before, this n and this n must match. My first term is a 1. My common difference is 3 right here. So 7 minus 4 is 3. 4 minus 1 is 3. So I have identified these are the two things that I need to know, along with which term are we looking for. Now, once I have this, and I substitute in a 20 and a 20 right there, and these two must match exactly, I'm going to put this part exactly like I said into my graphing calculator. So I'm going to put this in. I'm going to put in 1 plus parentheses 20 minus 1 parentheses 3, close it off, and there is my answer, 58. So the 20th term is 58. Now I could, if I wanted to, I know the first term and I know that the common difference is 3. I could say plus 3, and I could go out 50 places, but it's going to take me a long time to go out 50 places, and I would hate to have to count all those numbers all the way up to 50 places. So, or the 20 places. So instead, we're going to use the explicit formula right here. Now, look right here for the 30th term. Your 30th term, remember, these two must match. Right here, the ends must match. The first term is negative 10 right here. And your common difference right here is a negative 5. And I have made a mistake. So when you're looking at this right here, and I'm going to correct that right now, this should be a negative 5 right here. So I'm going to turn this into a negative 5 right here. So I'm going to put a negative 5. And now my common difference, and that's not too good. Right here, let me rewrite it. If I could get my pen to go in. So I'm going to put a negative 5. Now I'm going to bring up my calculator. I'm going to erase this right here. and I'm going to take this right here and I'm going to put it back into the graphing calculator right here. So I'm going to put in a negative 10 plus parentheses 30 minus 30 minus 1 parentheses, and my common difference is a negative 5. Put it in and I see that my answer is a negative 155. So I had it right. I just miswrote that. Now, looking at this next one, my first term is 3.3, so I'll put it in there. We're looking for the 25th term, and my common difference is 1.5. If I were to put all this at one time in the graphing calculator, just like we've done, it will give you 29.7. Now, we're going to do the same thing for each one of these. Notice you have to have the first term and you have to have the common difference. Once you have that, then you just simply put it in the explicit formula. So the explicit formula is used when we are looking for a certain term and we don't want to have to sit there and go all the way through the graphing calculator and count 1, 2, 3 like this. Go up to 30 times, go out 30 places. We don't want to have to do that. So we use the explicit formula instead and substitute in to this. Put all this at one time in the graphing calculator, you come up with 300. Now, same thing right here. You're looking for the 40th term. You don't want to have to sit here and go and use the explicit formula like this. We know the first term of this is 12.25 and hit enter. And I'm going to add the common difference of 2.25 to it. And we have to go out 40 places. So 1, 2, 3, 4, 5, and you count out, and you don't want to have to do that 40 times. So instead, just simply put all of this at one time in the graphing calculator, and you come up with a 100. Now you're going to do the same thing for this. Simply substitute 3.3 in place of this, and you come out with a negative 44.7. So recursive formula is fine if you know the previous term, and then simply add the difference to it to get the next term, and that's fine. But if you need to find a certain number, a certain place, the explicit formula is the way to go all the way. Now, when you're looking at these are looking at real world problems. So number 15, you've got the odometer on a car that reads 60,473 on day 1. Every day the car is driven 54 miles. If the pattern continues, what will the odometer reading on day 20 be? So we have the first term and we have a common difference right here. So we're going to substitute that in, our first term, and we're looking for day 20. So 20 and 20 must match right here. Put all this at one time in the graphing calculator and you come up with 61,499. So I'm going to substitute this in just like we did before with the other problems. I'm going to put in 60,473 plus parentheses 20, and we're looking for the 20th day minus 1 parentheses, and we're averaging 54 miles a day. So when I put this in, you see that if this pattern continues, we'll have 61,499 miles on the odometer. So now look at number 16. Rachel signed up for a frequent flyer program. She receives 4,300 frequent flyer miles for her first round trip and 1,300 frequent flyer miles for each additional round trip. How many frequent flyer miles will she have after 5 days? So the first term is 4,300 and your common difference is 1,300. Substitute that in and you're wanting to know how many miles will she have after 5 trips. So I'll put the 5 right here, 5 right here. First term and your common difference 1,300. So after 5 days she'll have 9,500 miles. Now look at number 17. Each time a truck stops, it drops off 250 pounds of cargo. So that means it's going to get rid of it. So it's going to be a negative 250 right here. We're not adding to it. We're taking away from it. So after one stop, the cargo weighs 2,000 miles. How much does the load weigh after 6 stops? So the first term is 2,000. The common difference is a negative 250. I put all the information in and we were looking for stop number 6. And so after stop number 6, the cargo truck will weigh 750 pounds. You can just put all of this right here at one time into your graphing calculator and come up with the 750. Now on this right here, you're doing the same thing as what we just did right here. This though is in a chart format, and I'm going to show you a different thing to do with this. You're still looking for the first term in the common difference. You have a student loan that needs to be paid off beginning the first year after graduation. Beginning at year 1 after graduation, there's $52,000 remaining to be paid. The graduate makes regular payments of $8,000 each year. So the first term is $52,000, and we're going to pay off $8,000 a year. So that's going to be a negative $8,000. You're going to substitute it in to this formula just like always. And then after the first year, you've got $52,000. Second year is $44,000, and it keeps on going. Now, when we're working with a series like this, we can take this and I can put in this information right here, 52,000 right here, plus, and we're going to put in the n, and we're looking for the first one, 1 minus 1 right here, and the common difference is a negative 8,000. So I'm going to put in negative 8,000, and you see that we have 52,000. I'm going to come up here and I'm going to copy that. See how that is highlighted? I'm going to hit enter, and then I'm going to come back over here, cursor back, and substitute in a 2 and hit enter, and now it's 44,000. I'm going to cursor up here, hit enter again. I'm going to cursor back and put a 3 in there, substitute a 3, and it's 36,000. I'm going to keep doing this all the way through here, and this time it's going to be a 4, and after 4 years you have 28,000, and we're going to keep on doing it over and over again. The 5th year, and it's 20,000, and then this last year is, after 6 years, you will have 12,000. Now, you can work this one by one, just like we did. You can type it in, or you can copy up here and hit enter once it's blackened in, and then cursor back and change it out, just like we did. So after 7 years, we could say we just have $4,000 left. Now, there's another way to do this. I can go to y equals and notice that plot 1, plot 2, plot 3 are not blackened in. If any of these plots right here are blackened in, it will not work. So simply cursor up to it, whichever one that is blackened in, whichever one it is, and hit enter and cursor right back off, and it will not be blackened in. So make sure none of these are blackened in. So I'm going to type in the explicit rule of 52,000 plus. Now, when we're working with the graphing calculator, we cannot type in the letter N right here. This funny looking key right here, this X, is the only thing that we can type in place of any variable that we need. So I'm going to put parentheses and type this right here, X minus 1 parentheses. Then parentheses again, negative 8,000, and hit enter. Now I'm going to go to second and graph. And when at second and graph, notice after the first year, I have 52,000 right here. After 2 years, 44,000. 3 years, 36,000. 4 years, 28,000. 5 years, 20,000. And after 6 years is 12,000. After 7 years is 4,000. So I can take this right here and go to y equals, type in my original equation. Remember, you cannot type in an n and it's X stands for any number or year that you need right here. Now once you have it, you're going to go to second and graph, because you want this table right here. Now if you needed to go backwards, if your table's not there yet, because this goes all the way to negative numbers, go down right here and you're looking for the X right here. This is your X, your N. So these are the numbers that you need, and here's the money that you owe right here. Now, looking at number 19, you've got a grocery cart that is 38 inches long. When the grocery carts are put away in a nested row, the length of the row depends on how many carts are nested together. Each cart added to the row adds 12 inches to the row length. So I'm going to set up my formula using the explicit formula. So my first term is 38. My D right here, my common difference, is 12. So think about stacking in chairs or carts. If you were to put one cart, you've seen carts in the Walmart parking lot and Kroger's parking lot, just shove one into the other. This is what we're talking about right here. So I'm going to substitute this in, and just like before, I can clear this right here, and I'm going to get out of this, and I'm going to go to second and 0, or second and on, and that turns it off. Now I'm going to turn it back on and hit clear. I'm going to substitute in 38 plus parentheses, and I want a 1 this time. 1, oops, let me back up a minute. And yes, it's going to be 1 minus 1, parentheses, and the common difference is 12. And you see that the answer is 38. I'm going to cursor up here, hit enter again, and I'm going to back this down, and after 2 carts shoved together, then it's going to be 50 inches long. And I'm going to keep doing this all the way through until I come up, see how long 6 carts would be. And you see that it's 62 inches. Now I'm going to go and use that little shortcut I did before. I'm going to clear this off. I'm going to type in 38 plus parentheses. Remember, we cannot type in an N here. We have to type in, using this key right here, an X minus 1, parentheses, and my common difference is 12. I'm going to type that in. And now I'm going to go to second and graph, because see this blue button right here? That goes with everything blue in the background. So we want our table to show up. So we're going to go to second and graph so that our table shows up, and we just graph that. Now I'm going to go again, second and graph. Now my table shows up. And so when I look at this right here, you see that one card is 38 inches long. Add a second one to it, it becomes 50 inches. Add a third one, is 62 inches. Add a fourth cart shoved together, and it's 74 inches long. Add a fifth cart together, it's 86 inches long. Add a sixth cart to it, and it's 98 inches long. And if you added a seventh cart to it, it's 110 inches long. Now you can just keep going on and on and on and on forever and ever and ever. So this is how to use working with explicit formula and recursive formula. So make sure you've identified the first term and the common difference. First term and common difference. Now, when I look at that is the explicit formula is what we just did.